Okay, now our experiment is over, and what we need to do here is we want to take the output file that we have created in the client node. We want to download it locally to our PC, and then use the GNU plot software to actually create a graphical representation of some of the parameters that have been recorded, of the values of these parameters that have been recorded during our TCP experiment. So in order to download this file from the iMinds virtual world node to our local PC, there are various ways we can do this. One of these is actually use the FTP, the file transfer protocol, and connect to the client and download the file. We need to say here that since this node in the iMinds already supports SSH, this means that it already supports the secure file transfer. So we don't actually need to install here an FTP server and download the file. We can easily use the sftp command to download the file, and let's see here, we can actually connect, copy. Okay, so I need to clarify here the following. These are two different connections to the client node. This connection over here, we have done it using the SSH tool, and this is actually a terminal where I can form every Linux command I wish. This, on the other hand, this is an FTP connection there, and I can only perform FTP commands. This means that if I press the question mark and then enter, I will see the list of commands that I can perform in an FTP connection. For example, if I press here clear, this is an invalid command. Anyway, in this terminal right now, in this connection, I can see that there is this file, the TCP out, which is actually, this is the same node. And if I want to download it to my local PC, all I need to do is run the command mget tcp out. Simply this. And now this file is, I am downloading this file from the remote node in the iMinds virtual world to my local computer. What I want to say here is that this file is actually large, and my connection at this specific time is not really good. So I have already downloaded, and I will leave it as it is. I have already downloaded and put it, as you can see here, in this folder. It is right here. So I can open it so that you can see that it is the same file. Okay, it's a large file, so we need to wait. Okay, here it is. As you can see, this is the same file. It's already in my computer. So what I'm going to do here is I'm going to run a series of GNU commands in order to describe a graphical plot, a graphical representation of some of the columns inside this file. what I want to actually represent here is the column 7 and 8, 1, 2, 3, 5, 6, 7 and 8, these two, which actually represent the slow start threshold and congestion window parameters. So this is the command that I'm going to execute right now. So I'm going to press, as you can see here, it's the 7 column for a congestion window and 8 for a slow start threshold. So if I press enter here, you will see that this is a graphical representation of the parameters for congestion window and slow start threshold that we have collected during our experiment. As you can see here, there are there are too many values, so it didn't. Okay, it's still working. So there are 3 different, let's say, areas here. As you can see, there is the first and the third area where TCP seems to behave smoothly, and then there is here this this area where, as you remember, in here we inserted a 5 millisecond delay in the link between the client and the server. So what I'm going to do here is I am going to zoom in at this specific point. Okay. And over here you can see for this is time in seconds, for about 16 seconds or more, anyway, how the TCP congestion window and slow start threshold is behaving at that was behaving at that specific moment. So I am not going to talk anymore about TCP. I'm not going to go into details about what these parameters and about what this graphical interface means. Anyway, the whole point here was to be able to collect these values and represent them with a graphical tool, which is GNU plot. So I'm going to stop this video here, and let me close this. No, before closing everything, I need to show you that okay, we have ended everything. It's time to clean things up. So here in the client console, I will type exit so that I will disconnect from the virtual from the remote node. I have already disconnected from the server, so everything is okay there. Here, do I have already? Okay, this is still downloading, so I'm just going to stop it. Okay, so then we need to go here to the virtual wall website, and we need to deactivate our experiment. The reason that we need to do this is because currently we are using 3 nodes, and okay, you don't want them anymore. Of course, if we do not deactivate our experiment after 4 hours, as you can see here, our experiment will be automatically deactivated. However, there is no point in reserving for 4 hours 3 nodes in the virtual wall. So what we need to do here is click on this menu, the swap experiment out action, and if we click confirm, then we will see here that the virtual wall is actually deactivating our experiment, and it's releasing all the resources that we were already using for creating our TCP congestion control experiment. So as you can see here, if we go to our profile page, we will see that the experiment, my first experiment, is deactivated. So that's it from me. I hope you enjoyed the video. I hope you understood as much as possible about you may say, complex process of creating manually a TCP congestion control experiment. And for any questions or any other business, feel free to contact me or the virtual wall administrators. Bye-bye.